5:01. I think we can get started. Anybody who doesn't show up, I'm not waiting on people. I don't trust the weather on a day like today. Hey. Am I right not to trust the weather on a day like today to get people here?
Yeah, I agree.
Like, if I knew that this was going to be recorded and I could just watch it later, knowing me, I might not be here. I don't know. No, knowing me, I'd be here. I am here. We got 170 problems to do anyway. The first 20 or so are all like true, false questions. And I've gone back to the strategy of having them printed out so I don't have to switch between screens. Also, the answers are up there. So if you're just here for the answers, good on you, I suppose. And this will also help us sort out whether or not something's going to be wrong in the answer key if it's been marked incorrectly otherwise. It does, however, handicap us in terms of me making you think about what the answer to a question is. For questions that are conceptual like these, verse 20, I'm less concerned at this point about trying to force us to think our way through these problems. I remember what happened at the end of last time. It was a little bit of a challenge for the end of last time, but at least for the problems about 25 and on, when we're working through hypothesis tests, the only thing I'm going to have to do is say, here's the scenario, and then we'll work through the hypothesis test. And then we'll come back and answer the questions. But we'll get there when we get there. Or I can try to be, I can use stratagem like this. All right, we already know the answer is true here. But number one, an alternate hypothesis is a statement about a population parameter that is accepted when the null hypothesis is rejected. There's effectively two hypotheses every time. There's a null hypothesis and a research hypothesis. Both will be statements about the null. Both will be statements about mu, but it could be something like that. But this is the alternate hypothesis, sometimes called the research hypothesis. One is true, and I'll give you that one. But two, for a one-tailed test with a 0.05 significance, the critical Z is 1.645, but the critical T is 1.96. How would we go about answering this question? What do we got to do? Where do we go? Where do we go for critical value? Critical values come from the table. All right. There's also something else that we can immediately tell that the answer to this question is false. Why do we know the answer to this question is false without even going to the table? Drew? Yeah, if you're going to come up with a T statistic, you need degrees of freedom, and we don't have degrees of freedom. So this one has to be false. Cool. 2 down, 168 to go. 3, the level of significance is the probability of rejecting the null hypothesis when it is actually true. The probability of rejecting the null when the null is actually true. So we talked a little bit about type 1 and type 2 error. And alpha is type 1 error. And if you're going to make an error, type 1 is where you reject H naught, and type 2 is where you reject the research hypothesis. So for a question like this, the level of significance, which is alpha, is the probability of rejecting the null when it is actually true. So what do you think? Chris? True. True. Four, type 2 error is the probability of rejecting the null when it is actually true. And that's not the case. Oh, let's get a little bit better on this. Okay, we already said something. The type 2 error is the probability of rejecting the null when it's actually true. That's not the case, because type 2 error only occurs when you should be rejecting the null. Type 2 is I should reject the null and I don't. Type 1 is I should reject the research and I don't. false as well. And to be honest, I'm happy that I see so many bright, smiling faces today. I was commenting before that I don't know how you do it right now. I know that if I was 19 or 20 years old, this is not what I would be doing on a Monday evening. I know what I was doing at 19 years old on Monday evening. It was watching Dragon Ball Z with an eventual, I don't know why I was watching that show. But welcome, guys. Welcome. I don't even like Dragon Ball Z. It's just what all the cool kids were doing, so I did it too. 4 down, 160 some to go. 5. A test statistic is a value computed for. A test statistic is a value computed from sample information that is used to test the null hypothesis. Chris, what's the answer? True. Yeah. That's true. A test statistic is computed. And what do you use to find a critical value? The table. What do you use to find a test statistic? Sorry? Critical value comes from the table. Test statistics come from the formula. Thank you, Katie. Formula. So that's something that you would compute from sample information. The test statistic is the only thing that contains sample information. 6. If the null hypothesis is false and researchers do not reject it, a type 1 error has been made. So the type 1 and type 2 error stuff, that can be a tough thing to wrap your head around because there's all sorts of things that are accepted and rejected. But we know a type 1 error is made when you reject the null. And you shouldn't have. This says the null hypothesis is false and researchers do not reject it. So this suggests that researchers accept the null, but a type 1 error can only occur when you reject the null. Based on the premise and the consequence, I'm going to say this one is, what am I going to say this one is? False. False. So it says false. Woo! 6 down, a whole bunch more to go. That's, by the way, page 1 out of 34. Buckle up. This is the long one. This is totally the long one. Hey, but things get easier. The Greek letter used to represent type 1 error is alpha. True or false? True. True. Easy. A p-value is a probability. Now, for those Tuesday, Wednesday, Friday, I sound like Dame Drops. Tuesday, Wednesday, Friday. For those people who are in the Tuesday, Wednesday, Friday classes, we haven't been introduced to p-values. So I'm going to rely on Monday student, either Drew or Luke, or anybody who's pushed ahead, or Chris, but you went to hear it today. Is a p-value a probability? Is a p-value a probability? Yeah. A p-value is a probability, true. In fact, for those of you who haven't been exposed to p-value yet, and we will be today, it's effectively what happens when you follow this procedure, and the z-value is your test statistic, and the probability is what's in the tail. That's how you get to a p-value. If I gave you nothing else, I hope that some of you could translate this. You get a raw value and convert it to a z-score using a formula, sampling error over standard error. Go to the area for the z table. You find out how much is left in the tail. And that area in the tail is your p-value. It is a probability. Nine. A p-value is the same as the stated significance value. What do you think, Luke? Is it the same as the significance value?
False.
False. What would it be as opposed to the same as the significance value?
opposite of?
It's not opposite of. I like to think of it as an alternative to. But yes, different from works for me. Thanks for playing along. Yeah, the p-value is an alternative to the significance level, because the significance level, in other words, your critical value, goes into your critical value. Critical value is either t or z, 1 or 2 tail, and requires alpha. So alpha is an input to your critical value. Alpha is pretty arbitrary, a point we've discussed a number of times, because when we encounter the farmer no problems and, well, there's not an alpha given, I'll just throw one out there and it doesn't matter. Well, it does matter in some circumstances, but it's arbitrary. The p-value is not arbitrary. The p-value takes nothing into account that the researcher might use as input. The only thing the p-value takes into account is the z or the t. In our case, we're going to use z's. It's false. 9 down, 161 to go. 10. Assuming the null hypothesis is true. So null hypothesis is true, means the research is false. Means the null hypothesis is true, means equivalence. The null hypothesis, equivalence, something like that. Null hypothesis is true means things are equal, not different. All those things are assume the null hypothesis is true. By the way, I haven't even read the second half of the question yet. If you read all the question at once, just like when you do the math problems, you can get caught up in a lot of noise. You can get caught up in a lot of, it's a complicated problem because there's many parts to the statement. Take your time and write all over this. When you got true-false questions on your exam, make sure you get synonyms in here. However you best understand the statement, null hypothesis is true. Maybe it's things are equal, maybe not different. However you understand it. A p-value is the probability of observing a sample value greater than and or less than the observed sample observation. Oh my gosh. There's a lot more stuff in the second half of the problem. Well, a p-value is the probability observing a sample value greater than and or less than an observed sample observation. Well, this is a type of question that I think of an answer to. What words in there settle with you? What seems to make you uncomfortable? Take a crack at it. If you think it's true or if you think it's false, what makes you think one thing or the other? Chris, what do you think?
I think greater than or less than is not directional. Does that have anything to do with this?
Okay. Greater than and or less than. If it's or, greater than or less than, if it's either one of those, as opposed to just one of them, that could help us think about whether it's directional or non-directional. I think that has less to do with it. Jane, what do you think?
Doesn't it have to be equal, greater than or equal to the sample value?
What has to be greater than or equal to the sample value?
The probability of observing it has to be.
Observing what? I'm getting kind of specific on some of these words. What's a synonym for sample that I always use? As opposed to saying sample minus population, sometimes I've been known to say
Expected minus observed.
yeah, I'll say observed minus expected. And I'll say that sample values and observed values, will you observe things from your sample? For me, a question like this is designed to make sure you understand that sample and observation mean the same thing. Because the sample is the only thing that you can observe. To me, saying this is true, don't like this wording of this problem. I'm throwing it out. That's how I roll. Worry not, young Padawan. Something like that, if that's the thing. I don't like that question. That's the thing you can be mindful of when you read true-false questions, is the types of words that come into play. I would call this false on the basis of observation and sample value are the same thing. You wouldn't want to compare one to the other, something like this. But more than not, I have to learn to write more direct true-false questions. So with a level of complexity like this, I don't like that. Starting to think about and starting to write your exam questions, I recognize that that's the thing that I have to be much more direct about. Anyway, number 11. What does the null hypothesis make a claim about? The null hypothesis always makes a claim about one of those things, and this one's much more clean. Yeah, Jake?
Population parameter.
Yeah. Always makes something about a population parameter. Never talks about sample, doesn't talk about error. It's not the sample statistic. All right, 12. 11 down, 159 to go. The level of significance is, level of significance here. What do we mean by level of significance? Oh, thanks, Rick. The level of significance is also known as alpha, and alpha is the probability of what? Probability of type 1 error. 12D. All right, here's the type 2 error question. This stuff can be tough. First of all, if the null is false, because we're trying to define a type 2 error, if the null is false and you reject it, have you committed an error? How about this? Hey, Gabby, the sky is red. Do you accept or reject that statement? You reject that statement. Was my statement true or false? It's false. You have rejected a false statement, and you are correct in doing so. If you reject a false hypothesis, have you committed an error? No. However, failing to reject a false hypothesis could be an error. Rejecting a false hypothesis, again, can't be that. So one of those two things is a type 2 error. Either failing to reject a false null or accepting a false alternate. B, failing to reject a false null. So a false null suggests that you should be accepting the research. And failing to accept the research, hypothesis, that seems reasonable. Accepting a false alternate, yeah, that's the same as accepting a true null. Yeah, not exactly the same. The false alternate.
Would that be type 1?
This would be type 1. Because if the null is true, yeah, you missed it. $14. What is the probability of making a type 2 error if the null is true? So if the null is true, we're saying that is the one which we should accept. We're going to make a type 2 error. A type 2 error, again, is where you fail to reject a false null. If the null hypothesis is true, if these two things are in reality equal, is it possible to make a type 2 error?
No, because the type 2 error is accepting a false null.
Yeah.
So, therefore, there's a 0% chance of that happening if the null is true because you're accepting the null anyway.
Exactly. Looking at it, again, graphically, maybe that's a little bit better for some folks. We're saying the truth of the matter for a type 2 error, we're saying this is what we should conclude. We should be accepting the null. If the null hypothesis is actually true, well, it's what we are doing. You're always gonna, or you're never gonna make a type 2 error if what you should be doing is accepting the null. Another name for the alternate hypothesis. What's another name for the alternate, Chris?
Research.
Research hypothesis. Very good. Hey, and that's 15 down, and then we're on to math problems. I understand that one of the bigger challenges from Module 10 is type 1 and type 2 error, and different circumstances under which type 1 and type 2 error can occur. What I really want us to be able to walk away with in terms of type 1 and type 2 error is this. They're mostly affected by sample size. And if you're going to remember anything about type 1 and type 2 error, it's that. Is that if you have a very small sample size, you're likely to commit a type 2 error. Because a small sample size means you're probably going to accept the null, no matter how big the difference is or how real the relationship is. Simply as a statistical artifact of a small sample size means you're probably going to accept the null no matter what's true. On the other hand, if you have an excessively large sample size, you're always going to reject the null. And if you're always rejecting the null, you're probably going to be rejecting the null under some cases where you should be accepting it. And if you reject the null when you should accept it, that's a type 1 error. But big sample size means you're always rejecting the null. In some cases, you probably shouldn't. Big sample size leads to type 1 error. Excessively big sample size leads to type 1 error. Excessively small sample size leads to type 2 error. The rest of what we have to do, and it looks like from here on out, is work on some hypothesis tests. Now, the way most of these questions go from part to part is that there are some 10 parts. I do want a little pace check to make sure I don't get too talky-talky, and if you want to grind out some math problems, we can grind out some math problems. I can do that. I like to be able to pepper in thought where I can, but if we want to work on problems, we can just work on problems. So for this first one, I'm going to take it about as slow as I want to go. If you want me to move faster, you let me know. So what we have for this first problem is the following information. A sample of 36 observations selected from a normal population. We know that the sample mean is 12, the population standard deviation is 3, and we want to use the 0.01 significance level to test that set of hypotheses. There's going to be a whole bunch of questions which follow. For example, what is your expected value for the mean of proportion? All right, I've given it away that the answer is A here. In other words, that value is always your expected value, even if it's not given to you in the preamble. But in terms of our expected information, we know that mu is 10 because it's given in the hypothesis. Our sample mean is 12. based on some of those rules that we have used before, I see this sentence says the sample mean is 12 and the population standard deviation is 3. That 3 must be sample standard deviation because it's in the same sentence as the sample mean, right? No, why not? Because why, Stephen? Because it straight up says that. In the case of this sentence, that comma serves as an addition to the coordinating conjunction and separates that into 2 separate clauses. The second clause actually lives as its own sentence separated by and a comma. In this case, we have 2 separate sentences that are not separated by a period. The sample mean is 12. Yes, X bar is 12. The population standard deviation, sigma, is 3. Alpha is 0.01. I forgot my sample size. What's my sample size? 36. Ooh, I like that number. Now I'm going to come back to what the questions are after we've conducted the hypothesis test. It's much easier for me to just do the hypothesis test first than walk through the questions. Although in some cases, the order in which those questions are asked can guide you along the process. But we've extracted the essential information. Is this a hypothesis test from mu or pi, mu or pi? How do you know mu or pi? Katie?
Mu.
How do you know?
It's sample and it's given.
But tell me more about its sample and its given. What do you mean by that?
Like in the problem, it states that a sample of 36 observations.
We're always going to have a sample observation. That doesn't tell me that we're talking about means. But what can tell me that we're talking about means? Sharon?
The standard deviation.
Yeah, we see the word standard deviation. What other words do we see, Billy? Average. We see the words average, we see the words standard deviation, and we're given mu. So that must mean we're talking about mu. We got 2 hypotheses given to us in the problem. Mu, and according to the problem, mu is either less than or equal to 10, or it's greater than 10. Directional or non-directional, and how do you know? James?
Directional.
How do you know?
Because we're using it's because we're using greater than or less than.
Yep.
We're not using equivalents.
Yep, because it says, in this case, that says greater than. It's not the one that looks like the L. That's still how I read that. That's not an L, so it must be greater than. And if we've got greater than or less than, it must be directional. How many tails in a directional hypothesis? 1 tail. Which side of the distribution is that tail going to be on? Step 3, draw a picture. That side. Which side is that, Chris?
Right side.
Right side. 2 ways you can look at it. 1, this symbol means greater than, so put it on the greater than side. Or this shape kind of looks like that shape. That way you can put it on that side. What is the name of the valley which separates the distribution into the region of acceptance where we accept an all, the region of rejection where we reject an all? Caitlin. Caitlin, yeah, this is Caitlin. Sorry, brain farted there. Yeah, yes, it's called the critical value, and I also wrote it up there. Where do critical values come from? What 3 pieces of information do we need for critical value? Yeah, close. We got a couple pieces of information. 1, we definitely need alpha. 2, do we need degrees of freedom in this problem? Tiffany, why do you say no? Yeah, sigma means we need z. And if we're using z, we do not need degrees of freedom. We have critical value and a test statistic. At critical value, we have alpha, z as opposed to degrees of freedom. And what's the other pieces of information that we need in order to get there? Chris? Nope, I'm trying to find the critical value. We need alpha, we know z. There's one other piece of information that we need, Gab. 1 or 2 tails. How many tails, Gab? 1. In this case, we need a z value because it says z. Z because we're using sigma. It is a one-tail problem where alpha is 0.01. Critical value, 2.326. This is acceptanol. This is rejectanol. Test statistic comes from a formula. Same one we've been using for a while. Sampling error over standard error. Sampling error is the difference between what we observe minus what we expect, divided by standard error. How do I calculate standard error? There's a two-part formula. Bill?
Is it sigma over square root of n?
Yes, sir. Sigma over square root of n. Sigma is 3. Square root of 36 is n. That looks like 3 over square root of 36 is 6. Don't make me get a calculator out to tell you this is 0.5. I don't have a calculator today. As a wise person once told me, after that, statistics is just plug and play. So I have a formula, and I have standard error equals 0.5, and I'm going to plug it in there. X bar equals 12 because I wrote it. Mu equals 10 because I wrote it. 12 minus 10 is 2 over 0.5. What's that get me for a test statistic? How many's? 4 many's. 4. There's my test statistic. Do I accept or reject the null? I'm going to reject the null. I'm running out of cruel ways to reject the null. And I think I may have gotten a little too serious last time I did that. So I'm just going to draw a line through it. Cool. That's the hypothesis test for this problem. My expected value is the value that's written in here. Expected value is 10. What is your observed mean proportion? What did we observe? 12. Was it directional or non-directional? Directional. How many tails in the directional test? 1. What is your significance level?
101.
What's the appropriate test statistic? T or Z?
Z.
Z. How many degrees of freedom?
None. D.
Does not apply. What's your critical value? I don't see it there.
Probably D.
Oh, probably D. What's your sampling error? Observed minus expected. 2. What's your standard error? What is your test statistic? 4. What do you do to the null? Reject the null. Oh, there's actually, what, 13 parts to this problem? Yeah, 13 parts. The last thing we have to do is calculate the p-value. It's one of those 3, and I'm going to tell you that it's 0. I'm going to tell you that it's 0 because the p-value is the tail cut off by test statistic. So if my test statistic Z equals 4, and I come to this table and I see I don't have 4, but I got 3.90, the area is 0.5. 0.5 subtracted from 0.5 means that the area in the tail cut off by the test statistic is 0. Now it's up to me to interpret what that p-value is as an alternative to using a critical value. But if that p-value is small, then I have a lot of evidence to reject the null. If that p-value is large, I don't have a lot of evidence to reject the null. And then we just got to come up with some rules as to what's small and what's big. As soon as we get that far, p-value is far superior to critical value. 28 down, 142 to go. We're just a little behind pace to get to $1.70 in 2 hours, but was that too fast, too slow, or just right in running through the hypothesis test? I see Billy's thumb, I see Katie's thumb, I see Chris's thumb, I see Phil's thumb, I see Rudy's thumb, I see front row thumbs, and we're hitting triple Steph. You're not Steph. Like Steph Curry. I mean, what else would I be referring to? Does anybody know about his foot? Is he playing the association?
You didn't participate in warm-ups today?
No warm-ups today?
Yeah, you do it. So it's much cool.
All right. Well, he's spent a lot of games not playing anyway. Maybe he can mail in it. Thanks, Jeff. I really appreciate it. All this time doing stats, I don't have time to keep up on what's happening on the court. A sample of 64 observations is selected from a normal population. The sample mean for these 64 observations is 215 and the population standard deviation is 15. Conduct the following hypothesis test at 0.025 significance level. Let's pull out some information. What's some essential information we can get from this problem? Give me one piece of information, Chris.
N equals 64.
N is 64 observations. Phil, you got some too? No, I thought I saw a hand on the corner of the eye. Sorry, you can hop in if you want. Tiffany, what do you got? X bar, sample mean equals 215. What else do we got? Steven? Mu is 220 because that's what it says here. Sounds good. Right, I got a standard deviation. Billy?
Sigma, 15.
Sigma is 15 because population standard deviation equals is. 15 is that. One more piece of information we're given here. Connor?
Alpha is 0.025.
What a weird alpha. How about just picking one, not splitting it in half? Okay. I want to know directional or non-directional. How do you know, Chris?
Greater than or less than.
I've got less than. That means directional. How many tails in a directional hypothesis? One tail in a directional hypothesis. Z or T? Z or T? How do you know Z or T? Well, Z because I just wrote it. But how did I know Z or T? Chris?
Sigma.
Thank you. Feels good, right? There's a little rhythm here. I mean, I know this isn't all that new, but it's nice to be good at it. It's cool. Let's do some hypothesis stuff. I want to draw a picture. I need a tail according to that hypothesis. Should my tail be on the left or the right-hand side?
Left.
Left. That's less than, and less than sounds like left. Critical value is the name of the value which divides a distribution into a region of acceptance and a region of rejection. There are three things which I need in order to get a critical value on here. Hey, Caitlin, what are the three things we need for a critical value? Significance level, alpha, and then yeah, Z or T. Which one do we have here? Yeah, because that will determine your T or Z determines which row on the table that you use. Z is the bottom row on this table. I was helping somebody out earlier today who was in a stats class that is not mine, and the first thing I commented on was, by goodness, that's an unfortunate T table. It's only a one-sided T table. You have to do separate one tail, right tail, left tail. It was just a mess. Like, get your table action right. This is a good table. I like this table. It's got a row mark Z, which makes life easier. All right. Critical value, I need three things. I have alpha, I have the number of tails, and I know I'm using Z. It's a one-tail test, where alpha is 0.025, and I need a Critical Z of 1.96.
Negative.
What, Stephen?
Negative.
Negative, why?
It's to the left of the mean.
Exactly. The Z-score for the mean is 0. Always yes, forever and ever. Amen. We've got a critical value. Now we need a test statistic. Test statistic is calculated by sampling error over standard error. Boom. X bar, 215. Mu, 220. I still have to use sigma and my sample size to get a value for standard error. So when you calculate it for 15 over 8, you're welcome. 1.875?
Yeah.
Yeah, I like that. So that's just 15 divided by the square root of 64, which is 8. 15 over 8 is 1/7. I will ask for the assist on this one. Chris, yes, please.
You got negative 2.67.
Negative 2.67. Confirmation? I see 2 thumbs. Negative 2.67. Accept or reject the null?
Reject.
Reject the null. Then come back up here. You're a bad null. See, out of my life. And I accept the research hypothesis. I accept H sub 1, which is mu is less than 220. All right, time to run the gamut on these questions. What's the expected value? 220 or 215? 20. That's what's written there. What's the observed mean of proportion?
215.
The other one. Directional or non-directional? Directional hypotheses have how many tails? One tail. Directional hypothesis have one tail. What's your significance level? That thing that says your significance level. It says it right there. What's the appropriate T to Z? T to Z? Z, because you got sigma.
Wait, can you go?
What'd I do?
Yep.
Oh yeah, 34Z because I got sigma. Yep. 35, 35. What's the value for degrees of freedom? A does not apply because Z means don't worry about degrees of freedom. What's the critical value?
A. Negative 1.96.
Okay, let's go with that one, yeah. Now, don't get confused. It's negative because it's on the left side. I know we looked up in our table 1.96, but it's been a long time since I don't have negative values. My table is broken. Math is hard. I give up. We're done saying that. We know that that is a symmetrical distribution. We can use both sides. What's the value of the sampling error? Is it positive or negative? Negative sampling error, because what I observe is less than what I expect. What's the value for my standard error? That's the denominator in my test statistic.
1.88.
We're going to use double eights here. No men are no men in my life right now. 39. What is the value of your test statistic? Well, I mean, we already got there, so I don't care. That's what the answer he says. Negative 2.67. We did that one. 40. What do we do with the null?
Reject.
Reject the null. Time to come up with what our hypothesis, the p-value for the hypothesis test is. It's the area in the tail cut off the test statistic, which is 2.67. Z table. 2.60, 1, 2, 3, 4, 5, 6, 7. Yep. 2, say 4962. You take 0.5 minus 0.4962. I hope that number matches that number, matches that value. 41 down, 129 to go. You got to keep your mind of difference spry by constantly subtracting things from other things. How I feel? Where's the pace? Pardon me? Good pace? I mean, I'm running that hypothesis test about as fast as we can, but I think we're doing okay here. We haven't seen anything too different from what we've seen before. Because for the most part, again, we're given another hypothesis here. All right? We're talking about mu or pi. Mu or pi. How do you know mu or pi? That's a question I want to ask this time. We're talking about mu or pi. How do you know? Does it says it?
It says, mu 400.
Oh, yeah, because mu is written there. So we must be talking about averages. All right. So there's a bunch of information that we need to know in order to answer this question. That value is what we expect. All right. Somebody else hit me with some more information here. Billy?
407.
Yeah, X bar is 407. Anything else? Is that population or sample standard deviation?
Sample.
How do you know it's sample? How do you know it's sample standard deviation? It says it. I make a claim, you provide me evidence, everybody wins. Sam, what's the symbol for that? Sample standard deviation. Yep. Good on you. All right, what else? What else? What else? Look.
It's non-directional.
It's non-directional. How do you know?
Just not using a greater than or less than equals.
Yeah, so that means non-directional. How many tails in a non-directional test, Luke?
2.
Good. Other piece of information we have. Katie.
Alpha is 0.01.
Good. Other piece of information we have. Katri.
Minus 12.
And it's 12. All right. Looking good. Looking real good. We got to get critical values and test statistics. We're going to be using T or Z. How do you know T or Z? Black honor. All right, we're using T. We need to know degrees of freedom. How many degrees of freedom we got? How do you know it's 11?
It's 12 minus 1.
Yep. T needs degrees of freedom, or degrees of freedom is n minus 1. 12 minus 1 is 11 degrees of freedom. I don't know why I wrote something. Oh, yeah, because we need a critical value and we need a test statistic. That's stuff we need. Draw a picture. Now remember, on our picture, we're going to have 2 critical values. Hey, Luke, why do we have 2 critical values?
2 tails.
Yeah. Sounds good. We need 3 pieces of information for a critical value. What are the 3 pieces of information we need for a critical value? Group.
Alpha.
Alpha.
T2.
T.
And directional down.
2 tails. 2-tailed t-test with an alpha of 0.01. 2-tailed. Alpha is 0.01. We need T for degrees of freedom, which kind of provided to us as 11. 3.106. 2-tailed test. Alpha is 0.01. And we need 11 degrees of freedom. 3.106. And negative 3.106. Critical values. Divide our distribution into regions where we accept or reject the null. We got critical values, time to come up with test statistics. Hey, Jane, what's the formula for test statistic?
Sampling over standard.
Yeah, sampling over standard. Thank you. So my test statistic is sampling error or standard error. Standard error is S square root of n. S is 6. N is 12. Therefore, my standard error is 1/2. This is a FOE. This is an FOE. This is a frequently occurring error. Reynolds, what's wrong with my standard error?
Being distorted.
Thank you. Got to make sure you take the square root of 6 over 12, because it is not 1/2. That is wrong. Square root itself is 2 times the square root of 3, so it's basically 3 over the square root of 3, which sounds to me like square root of 3. Do you get 1.732, Chris? Yeah, you do. Because 6 over the square root of 12 is the same as the square root of 3. Which I think is 1.732. It's just digits in there now. All right. So we have a standard error, and we need sampling error, which is what I observe minus what I expect. Test statistic. 7 over 1 point. Wow. Aren't you a big test statistic? 7 divided by 1.732 is my test statistic, because it's 407 minus 700. 7 divided by what? Yeah, Jake, please. 4.04. Maybe 4.041. I don't know. Looks big. But our test statistic is 4.04. Which, if we put that on our picture, 4.04 is not in this region of rejection. 4.04 is in this region of rejection. You only ever calculate one test statistic. You don't calculate two. You may end up with 2 critical values, but you get one test statistic. And that test statistic can end up in either of those 2 regions of rejection, or in the region of acceptance. But if it does end up in either one of those, we reject the null. Do we accept or reject the null? Accept or reject the null? Accept or reject the null?
Reject.
Reject. Why?
Because it's greater than
Greater than what?
3.106.
Yep. It's always going to be a positive number is always greater than a negative number. That doesn't mean anything. It's the fact that 3.04 is over here, so we're going to reject null. What's our expected value? 400. What's our observed mean? 407. Directional or non-directional? Non-directional. 1 or 2 tail test? 2 tail test. What's the significance level?
101.
101. T or Z?
Z.
Z, because we had S. Degrees of freedom?
B.
11. Say 8? Except B.
No, I said 11, I said B. Yeah.
Alright. B looks like 8. I got confused. Critical value, 3.016.
No, it's A.
No, that's being, I don't know, trying to keep you on your toe picks. Negative 3.016 and 3.106. Because there's two critical values in a 2 tail test. The value of our sampling error, we observe minus expect. 7. Standard error, square root of 3. What was the value of our test statistic? Yeah, that looks familiar. What do we do to the null?
Reject.
Reject it. Time to come up with the p-value. Our p-value is based on our test statistic. Our test statistic is 4. So here's a new challenge for us. The challenge that we have here is that we can't use the z-table. Why can we not use the z-table for this test statistic? Chris? Very good. You can't use the z-table for the t statistic because t ain't z. They're similar, but they're not the same. So you have to use a little strategy that looks like this. You start by saying if you got a 1 or a 2-tailed test, you know it's going to be a 2-tailed test. Okay. How many degrees of freedom do we have? Well, we have 11. In fact, at 11 degrees of freedom, this is the only row that we care about. If we were talking about z, this is the only row we would care about. But for us, 11 degrees of freedom is the only row we care about. Our test statistic of 4.04 is between those two. What I mentioned before, which was something about what the p-value does, is it takes the arbitrary nature of alpha out of the equation. So we would say that if we had a test statistic of 4.04, and we suggested that our alpha was 0.02, we would reject the null. However, 002. We would have rejected the null if that was alpha. However, with our test statistic, had we selected that for alpha, we would not reject the null. So our p-value is going to be somewhere between those two. Because 4.04 is between those two. And the reason I choose those two values as opposed to those two or those two is because this is the row which corresponds to our degrees of freedom. Once we say 11 degrees of freedom, that's the only row we care about. So somewhere between these two is where we'll find our p-value. And in this case, 0.02, because that's the smallest p that we can reject at all. 54 down, starting to get winded. Losing a little pace for making 170 by 7. You guys meeting tonight at 7:16? How long you want to do hypothesis testing tonight? Anybody who wants to work on hypothesis testing all night, James will be your huckleberry. But for me, I still want to get done to 7. Part 5. 120 observations. I'll tell you that n equals 120 here. So a sample of 120 observations revealed that p is 0.3 at the 0.05 significance level. Can the null hypothesis be rejected? When that's my null hypothesis and that's my research hypothesis. I'll move it up on the screen so all y'all can see. All right. Is this a test for mu or pi? Mu or pi? How do you know? Mu or pi? Steven says pi. How do you know pi, Steven?
It's in the problem, you took 140, and then,
Easy. I don't need all those evidence. You saw pi, it's pi. Actually, you can say all you want. I always appreciate it, Steven. What's the easiest piece of information that we're talking about pi? Best piece of information? What's the first thing you said?
5.40.
Yeah. That's not pi. It's just pi. Hope we're there. Hope we're there. Good work, Steven. Problem about pi, so I got to know what pi is. I got to know what P is. I better have a sample size. I hope there is an alpha. Because I'm talking about pi, am I going to use Z or T? Z. We're going to need a critical Z and a test Z based on that hypothesis. Directional or non-directional? Directional or non-directional? Non-directional, why?
Yeah, equals and equals.
That always means directional. I'm sorry, always means non-directional. How many tails?
2.
2. What value do I set for pi? How much?
0.3.
Nope. Whatever value you see here, that's the value I'm just going to basically write that right here. That value actually tells me what P should be. So here I'm going to write 0.3. How many observations? How many?
120.
Yeah, 120. Thanks, Andrew. What's my significance level? 0.5. Hey, I think I'm pretty much on my way. Let's do a hypothesis test. The 2 hypotheses were given to me, and if I remember correctly, they were hypothesis tests from you, they were non-directional, and we must be comparing 2.4. Time to draw a picture. 2 critical values separate my distribution into regions of projection, regions of acceptance. Critical values come from the table. If I have an alpha of 0.05 and I need a 2-tail test and I need a critical value or values. I want a total of 5% on the outside, so I want a total of 95% on the inside. Something like a point. What do we want? Yeah, 4750 would be our area if we're going to go back that way. We don't need to go that old school. We don't. So we got that row mark Z. Who's got the row mark Z? A 2-tailed test with an alpha 0.05. Who's got it? Fabio carrying.
1.96.
And
Negative 1.96.
right. Cool. We got critical values. Time for test statistic. Test statistic is sampling error over standard error.
Different than using pi.
You're already reading my mind. So we're going to have to calculate a test statistic, which is sampling error over standard error. P minus pi, well, my sampling error is negative 0.10. Now I have to decide which of those 2 things I'm going to use in order to calculate my standard error. And if you have a choice between P or pi, which do you choose?
Pi.
Pi. In statistics and in life. If you have a choice between P or pi, choose pi. And again, I don't know if y'all went to Ray today. Maybe you put your name in the jar to hit me in the face with the pie. How many did you buy, Jamie?
I didn't go to that.
Liar. Make sure you put those names in the thing. When Emily asked me, by the way, Em's going to be the president of BGS next year, so I'm happy to be part of an event that she's running. She said, if you had a choice between getting hit in the face with pie, and I stopped her right there, and I said, I'll take pie, Emily, I'll take pie. Anyway, We gotta calculate our standard error not as square root of PQ over N, but rather pi times 1 minus pi over N. The standard error for the proportion is pi, which is 0.4, times 0.6, divided by 120. Seems like it's about 0.24 over maybe 11. So it's about a 10th, 0.24, maybe a little less. This is around 0.02. Oh, square root of that, 0.4? No, I don't know. Katie, what's the value of the standard error?
I can calculate it.
Oh, I thought you might have it. You
No,
answered
it
not.
just didn't sound right.
Nope, because I was just rambling. I don't know. Matt Christie's got me.
0.0447.
Confirmation? I see a thumb, I see 2 thumbs. All right. So aren't you a big test statistic? 0.1 over 0.04 looks like we're probably in the 2 range. What do we got for a value of a test statistic? Tiffany, yes, please. Negative 2.21. 2.24. And 2.4. And if you've got any question, when it comes time to answer the test statistic on question 65, yeah, it could be 2.21, 2.29, you go 2.24. Hey, that looks like a kind of a familiar number, but definitely wrong because it's not that. And oh, you didn't take that. Okay. Anyway, negative 2.24. Looks like I'm going to reject the null. We're going to run through all these problems real quick. But while we're on the test statistic, I want to calculate the p-value because there's the last caveat I need to give you about calculating p-values. I'm not going to hold you responsible for calculating p-values for t statistics. I don't think that's, I don't like that method. I'd rather have you use software if anything. But when you have a two-tailed test, like we do here, the p-value is the area which would be cut off by 2 tails. More simply stated, it's 2 times the area cut off by the tail. So Billy's got his thing there, and you look up an area for 2.24. What do you see? 0.4875, which means 0.0125 is the area left in one of the tails. Double that. That's how you find the p-value for a problem like this. Over here, negative 2.24. Go to your Z table. See 224.4875. What's left over here is 0.0125. But because you have 2 tails, we'll take 0.250. That's your p-value.
So if it's 1 tail, it's just the value that you get the first time.
Yep.
Okay.
Yep. It's 1 tail, it's just this. It's a 2-tail test, multiply it times 2. However you want to write that. So it's the number of tails times the area cut off by the test statistic. All right. Let's run it. The expected proportion is the proportion that's here, 0.4. The observed mean or proportion is what we observed. Directional and non-directional. Non-directional, because it said that one. 1 or 2-tail test. That means it's a 2-tail test. The significance level is the number given to the problem, which was 0.05. The appropriate test statistic, because we're using pi, is z. Degrees of freedom does not apply in this problem. I'm way zoomed in.
Yeah.
My bad. I got in a roll. Sorry, it happens. That's our observed portion. But this is all stuff we just did. I mean, bless you. I'm just answering questions. P is 0.3. It's non-directional because it's not equal to. It's a two-tailed test because it's not equal to. Significance level was stated in the problem. Because we have pi, we're using z. Degrees of freedom does not apply. We're talking about pi, more importantly, we're talking about z. Critical values, those two. Sampling error, observed minus expected should be negative. Standard error, yeah, oh, this one. That one looks pretty close, but it's not the right answer. How do you suppose you'd get close but not the right answer? So what? Not rounding.
Using the wrong test.
Yeah, using the wrong p or pi. If you use p, this is what you get. If you use pi, that's what you get. You're supposed to use pi, so that's the right one. The two standard errors don't look very different, but using the right one is important. Your test statistic, negative 2.24. We should reject the null, and we should reject the null. The p-value for the hypothesis test is something about 0.0253. The closest value we have. And we may have calculated 0.025 by hand. You do it electronically, you get something closer to that. $67 down, a whole bunch to go. I'm going to take a deep breath and say, is anybody forged ahead that's looked at problems and says, there's a particular problem I got a question about? Because I want to make sure that in the time that we have, we cover anything that anyone's got a question about, other than just like trying to get through as much as we can. Any specific questions from any problems? All right. I definitely want to make sure I reserve time to talk about the football question. And shut that off. Definitely want to talk about the football question because I like the concept in there. It's not because it's football, it's about flipping a coin. All right. Now we've actually got a problem where there's some stuff to read, stuff to be read. The manufacturer of the X15 steel-belted radial truck tire claims the mean mileage the tire can be driven before the tread wears out is 60,000 miles. Assume the mileage where it follows normal distribution and the standard deviation of distribution is 5,000 miles. Across the truck company bought 48 tires, which is a weird number to buy for 18-wheelers, just saying. 48 tires and found that the mean mileage for its 48 tires was 59,500 miles, 0.05 significance level. Can we say that Crossett's tires are different from what X15 claims? So Crossett bought 48 tires and found that their average mileage was 59.5. The X15s are supposed to get you 60,000. Is this a question about mu or pi? Mu or pi? How do you know mu or pi? Matt?
It's mu because we're talking about the average mileage.
Cool. If we're talking about averages, you better give me something to expect and something to observe for averages. You got observed and expected? Yeah.
Yeah. Mu is 60,000 and then X bar is 59.5.
Yep. Because that's the claim. 60,000 is the claim. 60,000 is what they say it should be. We've got a standard deviation in here. It says the standard deviation of the distribution is 5,000 miles. Is that a population or sample standard deviation? Katie?
Sample standard deviation.
And how do you know?
Because it says the distribution.
Well, that's the entire distribution. Had it been the standard deviation of the 48 tires that CrossFit bought, I would say it's the standard deviation of the sample. But in this case, we're talking about the entire distribution. We know the entire distribution is normal and that its standard deviation is $5,000 or 5,000 miles. So we're going with sigma on this one. But because it's sigma, are we talking about Z or T? Sigma means we're talking about Katie? Yeah. What's the sample size? How many tires did I look at for this one? 48. 48 tires. Do I have an alpha level? Do I have a significance level? Yeah. Whew. Time to come up with two hypotheses. They're both going to be hypotheses which pertain to mu. This is an inference we made about the tires that CrossFit bought, and we're going to compare it to what we expect. As we expect 60,000, we're going to make an inference about the tires that CrossFit bought. Time to decide if this is directional or non-directional. Directional or non-directional. Go to the question. Luke. All right, why?
Because we're trying to see whether or not the tires last more or less than 6,000 miles.
You said more or less?
Or if we're trying to see if the tires last, more or less than 6,000 miles.
So that's, you say directional or non-directional?
I say correct.
Which direction, more or less?
Because they last more than, or no, less than that.
Which one is it?
Less than, because the observed was 59.5.
Well, it's always going to be different from what you expect, regardless of the directional hypothesis. Where I need you to go is to the question mark, because the question mark indicates the question. And if you can find me a word in the question mark's question, which is more or less, those words that you're telling me we're asking about, then I'll agree with you that it's directional. But somewhere in that question mark with the question marked, if there is not more or less, bigger, better, faster, more, fewer, smaller, something like that.
It says different from what next. So we non-directional details, so just trying to see if it's different from the plan.
And that's what we're looking for. Different from. Different from is about one of the only examples I can give you for what a non-directional hypothesis would be stated at. But your instinct may be it's directional because we've observed a value less than what we expected. But for any type of hypothesis where what you observe is different from what you expect, the observation will be different in a direction that's either greater than or less than what you expect. Your observation, your expectation, and that comparison, effectively your sampling error, that does not determine the directionality of your hypothesis. The directionality of your hypothesis is determined by the question marked question, which in this case says different from. Quick callback to that nonsense about, true-false questions. Being more direct. Seems silly that I wouldn't ask the following true-false question. True or false, the null hypothesis always contains equivalence.
Yes. Yeah, it's true. Sorry, true.
Yeah.
No, yes.
One,
Yeah. It's,
because you're a robot.
yeah.
Yes.
It's true because it will either be equal to or it will be greater than or less than or equal to. So
Yeah.
it's one of those three things.
The null hypothesis, true, always contains equivalence. True or false, the research hypothesis never contains equivalence. Same justification. Those are nicer, more appropriate, I think, direct and assessing types of questions. Because when you have a non-directional hypothesis like this, and you know it's got to be equal to or not equal to, maybe your instinct says I'm going to put equal to in the research and not equal to in the null. Never will that be the case. The null is always equal to, and the research is always not equal to. Like that. Draw a picture. Two-tailed hypothesis has two critical values, which separate our distribution into regions where we accept the null or reject the null. I'm going to stop writing out the word reject because my hand hurts. I never write it out anyway. I always forget the first E. I have a z-test with an alpha 0.05 and two-tailed. Anybody got critical value or values for me? Two-tailed test for z. Tiffany, yes, please. Negative 1.96. Positive 1.96. Confirmation? Sounds good. Time to come up with a test statistic. A test statistic, which is the sampling error over the standard error. What I observe minus what I expect. And then that. Because when you have a choice between P or pi, you choose pi. Sharon,
That's not right.
what's not right?
The formula.
Why not?
Because we're not using pi.
Thank you. All right, so now I need to use observed minus expected over standard error. Standard error is the standard deviation divided by the square root of the sample size. Something like 5,000 divided by 7. CDS, please.
7.1.
You got a play. I 500 divided by 7. Chris?
500 divided by
That's fine.
6.9 equals 721.
Yeah, but it's 5,000. Standard deviation is 5,000, not 500. So we're off by an order, I think. James?
It's 721.688.
721?
Yeah.
Yeah.
722.
722 if we round right, yeah? 721.688 gets me 7 double digits. All right. 722. I can round to the nearest mile here because I know my sampling error is on that order. So sampling error 59500 minus 60K over 722 is negative 500 over 722. Means my test statistic is approximately 0.7. So that's what you were giving me? The test statistic, Chris? No.
Negatives.
What do we get for a test statistic there, Katie?
0.6925.
Negative 0.69. Let me just see if that matches our answer key, because it'll save us the trouble from, yeah. Because it'll save us the trouble from calculating the p-value wrong. So whether you float your decimal or you use something like Excel to do all the work for you, rounding can get in the way, but when you have multiple choice options like this, if you calculate something like negative 0.7 as your test statistic and the only options available is negative 0.69, I'd probably go with that one. Negative 0.69. What's our decision regarding the null? Let's accept it. All right. Time to run it. I'm going to run the joules, right? real quick. What is your expected mean? The expected mean is what they told me. What's the observed mean? Well, that's the one based on the sample. Is this directional or non-directional? Because it only said different from, that means non-directional. One or two-tailed tests, non-directional tests are always two tails. Significance level is the value next to where it says significance level, 0.05. T or Z, how do we know? Well, it's Z because we have sigma. Degrees of freedom doesn't apply here because we have Z. Critical values, we got two of them. They're $1.96. Sampling error is essentially what I observe and what I expect. We observed something less than what we expected, so it's negative 500. Standard error is that number on the bottom, which was 722. The value of the test statistics, not one of those. It's actually over here, negative 0.69. The null hypothesis should be accepted. We got to come up with the p-value. .69 for a Z means 0.2549. It's here, which means somewhere over here should be something like 0.2451. And that value looks pretty close to 0.2451. So I should very casually circle that before anybody corrects me from doing something I'll regret later. You could be my wingman any day. Thank you for keeping me from doing something that I would regret later. Yeah, we got to double this. This is a two-tail test. So we got to basically take 2 times 0.45, and that's going to give me something around 0.49. So whether you use the electronics or otherwise, that's your status. 80 down, 70, oh gosh, 90 to go. A lot of hypothesis testing. I've been told that our 7 o'clock crew or 7:15 crew is not meeting tonight, so I'll just power through for another half an hour because what else do I have better to do? I'll just keep working on them. Let's do it. Part 7. Or we got questions on this one? Or we want to just keep going? Yeah, let's keep it going. Let's keep it going. All right. The waiting time for customers at Mac Burger restaurants follows a normal distribution of the mean 3 minutes and a standard deviation 1. Warren Road Mac Burger, the quality assurance department sampled 50 customers and found that the mean waiting time was 2.75 minutes, otherwise known as 2 minutes and 45 seconds. If I had to wait 2 minutes and 45 seconds for a Mac Burger, I'd be fine, I think. At the 0.05 significance level, can we conclude that the mean waiting time is less than 3 minutes? Mu or pi, mu or pi, how do you know mu or pi? Mu, how do you know mu? Did you see the word mean? Do I see the word mean? Oh, I do. So it's going to be mu. All right. So that's some information that I'm going to need. What do I expect and what have I observed for the means? Wonderful. How many observations were required to get to that mean at 2.75? 50 observations. I imagine I need a standard deviation at some point. It says standard deviation of 1 minute, but I don't know whether that standard deviation is at population and sample level. Let's take a crack at this one, Kate. What's your instinct say? What's the population mean? What value do we select for mu? 3.
So would it be population standard deviation?
Yeah. So that's just a little bit where I'm just telling you, this is what the population says. It's a population mean of 3 and a population standard deviation of 1, and it's normally distributed. And then some people went out and got themselves some Mac burgers. So that is a sigma of 1. Jack Kate. Time to come up with a significance level. Can anybody read the 2 digits which come before the word significance level? You can, 0.5. All right. Essential information. And because we have sigma, we're using Z. And we need a critical value and a test statistic. Time to write a couple hypotheses. These hypotheses deal with what we believe the true waiting time to be, and it compares to the standard. Time to come up with directional or non-directional. Luke, I'm coming back to you on this one. Directional or non-directional?
It is directional.
Is it? How do you know? And if so, what direction?
We're trying to see wait time is less than 3 minutes, so it's extremely on left side.
Very good. Because it says less than in the question mark with the question. This is less than. Yeah, take a look at the part with blue. I think that'll give you a little more insight.
Okay.
Mostly has to do with degrees of freedom.
Great, thank
That's
you.
my conclusion.
Okay, thank you.
Good luck. All right. So, directional hypothesis, where according to the problem, it says less than. Katie, yes.
Is it always going to be to the left if it's less than?
Yes.
Okay, and then if it's greater than it's on the right?
Yes.
Okay.
Because this symbol is the less than symbol. So we want to know if the true waiting time is less than 3 minutes. Is the true waiting time less than what we expect
Okay.
or not? That's a horrible looking normal distribution, except for this side. This is the side that counts. Critical value is on the left-hand side, it's on the less than side. It's a one-tail hypothesis because this is directional. Alpha is 0.05 and we need Z. I need one tail, alpha is 0.05. One tail, alpha is 0.05. Give me a Z. 1.645. Thank you. There's another person that could be my wingman, reminding me to do the things I should do. Not just keep me from doing things I regret, but reminding me that some things should be negative. Cool. We've got a critical value which came from the table, which involved the number of tails, our alpha level, as well as our knowledge of whether we're using Z or T. Time to get the test statistic, which comes from the formula. Formula is
Sampling over standard.
sampling over standard. All right. Sampling error over standard error. I observed 2.75. I expect 3. My standard error is going to be sigma over square root of n. Probably like 0.12, 0.13,
0.14.
0.14. Yeah,
Standard?
standard error.
1.78.
I got
Oh, sorry.
It's 1.4.
Yeah, I'll go 0.14.
Yeah.
That seems reasonable. Ooh, this could be a close one because we've got negative 0.25 divided by 0.14 for our test statistic. That's a pretty close one because that's almost twice the standard error. What's the final answer here, Chris? Yes, please.
Negative 1.78.
Ooh. I don't know. Dramatic. It's a close one. Normally we're getting test statistics which are like 4 or 3. They're just, this one there's a little drama behind it. What'd you say? Negative 1.7 what? 8. Yeah. Negative 1.78. Folks,
Critical value divides the distribution in the regions where you accept the null or regret the null, apparently. I'm writing it now. Reject the null.
Or that sort of looks like right. Yeah, it looks more like right. No. We reject the null. Our test statistic is less than our critical value. Last thing I want to do is take that, find p-value. That was my test z of negative 1.78. Let's make sure that's the value that we were looking up from. Looks like we like negative 1.77. I'm going to use that one instead because that's the one that the answer key says. Negative 1.77. 0.4616 means the area in the tail for the p-value, 0.0384. How many tails in this test? One or two? One tail. So that's our p-value, and we're done. All right, run it out. What is the expected value? 3. That's what they told me. What did I observe? 2.75. Is this a directional or non-directional hypothesis? It's a directional hypothesis. It's directional because I have the word less. That's weird. I don't know if other people are going to have that, but the printer stuttered. Either one tail or one tail, but not both, because that would be 2. Just pick one of the one. Anyway, significance level was the word that was the number that was less significance. I'm guessing it was 0.05. T or Z? Why was it Z? Because we had
Sigma.
Thank you. Degrees of freedom does not apply. We're talking Z. Critical value, we had 1, and it was the negative 1.645. Sampling error. Well, I actually kind of like that one. Negative 0.25. Yeah. Standard error looks like it was, what was it, 0.14? 1 out of the square root of 50? Yeah, 0.14. Test statistic was something around B. We rejected the null. And we said our p-value is something around 0.0384, which is like 0.0385. 93 down, 77 to go. Still got 20 minutes. We're not even making under time. Hey, University of Toledo College of Business. What a great college of business. I don't know anything about it. I know about the preschool. They had a killer sandbox in 1984, but I don't know anything about its business school. Crappy blocks, great sand. Well, the research from the University of Toledo indicates that 50% of students change their major area of study after their first year in the program. A random sample of 100 students in the College of Business revealed that 48 had changed their major area of study after their first year of the program. What proportion did we observe changing their major? What percent changed?
48%.
Yeah, 48 per 100. Cent is 100. 48% per 100. 48 per 100 is 48%. 48% changed their major area after the first year of the program. Has there been a significant decrease in the proportion of students who change their major? Hey, Luke, is this going to be a directional or non-directional hypothesis, and how do you know?
It's going to be directional.
And which direction?
To the left.
Good, to the left. What word indicates all of that to me?
Decrease.
Thank you. We're not talking is it different. We're talking is there been a decrease. Decrease means it's a one-tailed and directional hypothesis. We're going to test this at the 0.05 level of significance. What's the level of significance? Make my life so easy. It's so easy. All right. The proportion we expect is the proportion that's given to us. And according to their numbers, research at their school indicates that 50% of students change their major. We observed, thank you, James, 48% of 100 students changing their majors. Daintree informed me that alpha is 0.05. And because we have pi, we're going to use T or Z? Z. I've come a long way with my weirdo mnemonics. For a while, I was trying to force the fact that pizza had pi and Z and was brown. Like, I tried real hard to find pizza a way to work that together. But it didn't so far stick around. As long as we got pi, we're talking about Z. So let's get pi. There we go. Lost pi for a minute. Found pi again. There we go. We got to get all this stuff. Time to write our hypotheses. Now, Luke helped me out and told me that these are going to be directional. And which direction did you say it is to, Luke?
To the left.
To the left. To the left. Bless you. Yes, bless you. And it's to the left. That means there's one tail where there's a critical value which separates our distribution to regions where we would accept the null or reject the null. See, I can write it sometimes. One tail, 0.05. Z as in pizza. Got a critical value?
Negative 1.645.
Thanks, Christopher. Does anybody call you Christopher?
No.
Now, he did say that in a way that was like, and you shouldn't do it again, right? Okay. You got it, Christopher. No, that doesn't sound right. I prefer Reynolds. That's not right either. What do they call you on the team?
What?
What do they call you on the team?
Reynolds.
Reynolds. You don't have like a
Knowles.
Knowles?
Yeah.
Okay. 1.645. Thanks, Chris. A negative 1.645. Cool. It's time to come up with a test statistic. Test statistics come from the formula, and as always, the sampling error over standard error. What we observe minus what we expect over what would be a big difference. P minus pi. Time to make a choice. Two ways we can calculate standard error. We can calculate standard error using P. We can calculate standard error using pi. I got to tell you, it's not much different in this case, but we should probably use the right one. It's also easier to calculate. P or pi, P or pi. Pi. 0.5 times 0.5 divided by 100 is 0.25 over 100, which is 0.0025. You take the square root of that. Looks like math should be getting easier. 0.5 is pi times 1 minus pi, which is 0.5. Divided by 100. Should be 0.5 over 10. 0.05. I don't know. What do you get for standard error? For real?
It's an answer.
Is it the right answer?
Yeah.
I think so.
I do too. Because the square root of 0.5 times 0.5 is just 0.5. The square root of 100 is 10. So 0.5 divided by 10 is the same as taking 0.5, moving the decimal place over just 1, 0.05. P is 0.48 minus pi, which is 0.5. Means you got 0.02, 0.05, rather negative 0.02, 0.05 means our test statistic appears to be negative 0.40. And if it's math I can do accurately in my head, I don't mind saving you the trouble of calculator punching. Accurately meaning there's like not a whole terrible amount of rounding. And there wasn't any on this one. As long as 2 over 5 is still 0.4. Is 2 over 5 still 4 over 10? It is. Do I still ask for a p-value? Hey, we're almost in the hundreds, guys. Yeah, I still ask for a p-value. So in order to get a p-value, this is a one-tailed test for z of negative 0.4. That one. Looks like that's my p-value. I just went to the z value of 0.4, found that the area was 0.1554, subtracted it from 0.5, and I'm left with what I presume to be the difference. I don't know, I'm feeling just a little cocky because I just did a bunch of math by hand and a bunch of math by head and got it right, so now I think I can do it all that way. Y'all have been there. If you haven't, a bunch of you have. That's just an inference I've made based on years of observation. Spoken like a true stats teacher. Don't worry, I'm not truly a stats teacher. I just act like one an awful lot. From the top, what is your expected proportion? What proportion does the research say? 0.5. That's what they say. What did we observe? 0.48. Directional hypothesis, because we use one tail, or rather, the directional hypothesis implies it should be one tail. Significance level was the value they said was significance level 0.05. Degrees of freedom does not apply. Oh yeah. Critical value looks like that one, and there should only be one. This should be a z statistic because we're working with pi. Sampling error was negative because we observed less than what we expected. Standard error is that number. Test statistic is that number. Our decision regarding the null is based on that arrow which pointed to accept the null. We calculated the p-value at the end, and I think it was, in fact, it was precisely that. There was no rounding involved with a z-value of 0.4. 106 down, 66 to go. Chriser.
Did you say you wanted to do like Amber?
Football problem. Yeah, that was when I thought I was going to leave at 7, but I mean, let's see what we have left. We got Kayak TV. We got some sort of real estate problem. We got celebrity living. Oh, fun. Are Paris and Angelina still celebrities? I forgot that I started getting loopy towards the end. What else am I calling? Farm associates can't sell farms. Things I do to make me chuckle. Clock in the UN report. Super Bowl coin toss. I did want to make, that's the last one. I think that's the last one. Oh, and I guess there's 184. Oh, there were more here than I thought. I thought there were 171, but apparently I added a problem. So all right. So I would definitely like to do 159 until the end. So I think I'm going to start there now. Unless there are ones in the middle between 101 and 158 that you'd rather talk about, I think I can go through at least the highlights real quick on them before we get to 159, just to make sure the appropriate decisions, the things like mu or pi, s or sigma, are appropriate there. But I think as far as like the demonstration of what's important, this kayak problem, I see the word mean, so I know I'm probably talking about means. I also want to know whether this is S or sigma. S or sigma. Who can tell me if this is S or sigma for my standard deviation? James?
Sigma, because it's a polynomial probability distribution. And they tell you.
Yeah. They're basically going through that first statement says, this is a normal distribution with the mean of that and a standard deviation of that. All of those are descriptions which are telling you this is population level information. So my standard deviation in this case is sigma. I also see in the part marked with the question, different. I don't see more, less. I don't see any of those. So that indicates that it's a non-directional hypothesis. That's the highlights there. For Farm Associates, a statewide real estate sales agency, Farm Associates specializes in farm property in Nebraska. Its record indicates that we're talking about mu because I see the word mean. Because of drought conditions, the agency believes the mean selling time is now greater than 90 days. Well, I see greater than, so we're probably talking about a directional hypothesis. I also happen to see increase. Those are two different sets of words which indicate that I'm probably talking about a directional hypothesis dealing with mu. A statewide survey of 100 farms recently revealed a mean to be 94 and a standard deviation of 22. So 22 is going to be the standard deviation, but is sigma or S? Sigma or S? Sigma or S? James, do it again.
S.
What?
It's going to be S.
Why?
Because it's from the sample data.
Yep. We're talking about this sample, this survey. We found that to be X bar and that to be S. The publisher of Celeb Living claims the mean sales for personality magazines that feature people such as Angelina Jolie or Paris Hilton sell 1.5 million copies per week, probably on average under the staple. A sample of 10 comparable titles shows that the mean sales is 1.3 with a standard deviation of 0.9. At that significance level, does the data suggest that our publisher is correct? I want to know, is this directional or non-directional? Directional or non-directional? What is your instinct, Caitlin?
Non-directional.
Non-directional, why?
Because if you like sell more or less, it probably.
Yeah, because this question is just, are they correct? Because we want to know, is this number correct? What we observed was that. I realized I was reading without showing you. My apologies. But they think this is true. We observed that. They could be wrong in either direction. I'm also going to say that the standard deviation is a sample standard deviation because it comes from that sample of 10 comparable titles. Question. And you. Flock in the UN report, the UN shows that the mean family income for Mexican immigrants to the United States is $27,000 per year. And then we look at a sample of 25 and found the mean to be 30,000 with a sample standard deviation, otherwise known as S, being 10 grand. We're asking with the question mark, are we correct? Directional or non-directional? Katie?
Non-directional.
Very good. You can be wrong in either direction. Super Bowl coin toss. Let's do this one. Finally. Coin toss is used to decide which team gets the ball in most sports. It involves little effort and is believed to give each side the equal chance, or the same chance. Sorry for dropping a word in there. In 45 Super Bowl games, Super Bowl always pits the National Football Conference against the American Football Conference. In 45 Super Bowl games, the NFC has won 31 out of the 45 coin tosses, whereas the AFC has only won 14 out of the coin tosses. Using the .01 significance level, test whether or not this is a fair coin flip. Mu or pi? Mu or pi? How do you know mu or pi? Matt?
I talk about probability.
All right, if that's the case, what value do I expect for the probability of success?
0.5.
0.5. I like that. I like this problem for that reason. I like the problem because it doesn't tell you the probability, but it's a coin flip, and it's supposed to be fair and equal. So we expect the pi is 0.5. Next part is we got to come up with a p. Give me a p. Give me a p.
Thanks, Jamie. Appreciate that.
I've been grinding for 2 hours. A little joke doesn't hurt.
Does P come from for the AFC proportion, 14 over 45,
Or
or the NFC?
Yeah.
45.
doesn't really matter because if you choose p,
Oh, because Q is going to be.
yeah. So if you choose p to be the AFC, then it would be 14 out of 45. If you choose P to be the NFC, it's 31 out of 45, in which case Q, for the standard error, is just the complement. So it could be fair in one direction or unfair in, or wait, it could be, if it's unfair, it's unfair. One side is benefiting and one side is not. So you have an expected proportion of 0.05 or 0.5. Your observed mean or proportion, here are your options. I'm going to cover up the answer so that you can decide. 0.69, 31, 0.5, or 14. Which of those are we going with?
A.
A. Has to be that one.
Okay. So that's going to be, we're going to use the NFC for P.
Yep.
Okay.
So we're going to go with, and I didn't do that math, but I'm pretty sure 0.69 is rather that than that. 45 is N. So we have pi, P, well, Q, we'll need it eventually, N, and alpha is 0.01. Now, if you're going to call someone a cheater, you better be damn sure that they're a cheater. Because you know what happens if you call somebody a cheater in the Super Bowl? Yeah, you do, because, well, welcome to the Super Bowl, what was it, last year? Yeah, you spend all year talking about how somebody cheated, but it's okay. Or if you're on the other side of the argument, how it wasn't really cheating, or there wasn't much evidence, or even if you do a statistical test of 11 out of 12 balls and what you observe minus what you expect in terms of PSI divided by the standard error suggests that there is a significant difference between the amount of air that should be in the balls and the amount of air that was in the balls. But that's just statistics. Time to do some damage with the hypotheses. We know again, pi, 0.5, p, 0.69, n, 45, alpha, 0.01. We got to come up with two hypotheses. One of which says this is fair, the other which says this is unfair, and it's a comparison to 0.5. One of which is fair and one of which is unfair. What would a fair coin toss be?
Equal to 0.5.
Exactly. This would be fair. This, somebody is having an unfair advantage. Someone is having an unfair disadvantage. But this is a two-tailed test. At the 0.01 level, pi means we need z, so we need a critical z and a test z. 0.01 for two tails. 0.01 for two tails. Means our critical value is 2.576.
You got somewhere else to be?
Oh. Tell Danny I said hey. I met him Friday. Yeah, tell him I said what's up. No. Yeah, tell him I said what's up. Yeah, see, good one. So remember a couple of things about the way we're testing this hypothesis. First of all, we're asking, is this fair or is this not fair? We're not asking, did the NFC have an unfair advantage? Because that would change this from a two-tailed test to a one-tailed test, and that would change our critical value. And we're saying not only is it two-tailed rather than one-tailed, we're saying alpha is 0.01. And that gives us a very, very, very conservative region of rejection. Our test statistic. What we observed minus what we expect. Choose pi. .19 over, I don't know what the value of my standard error is. But you got the standard error? Yeah, CD, what do you got? 0.075. I got some 0.069s, I got some 0.075s. Reynolds, what do you got?
Yeah, 0.0745.
0.0745. So it's about 0.075. You got a value a little bit smaller than that, so you want to double check that. That's an interesting ratio. That's, what do you get? I mean, well, we can see what value close to that we have available to us in our standard error. This is when it did that weird thing here. Standard error, 0.0745. Did you get 6.9, Stephen? It could be the case that you used p instead of pi. Did you use 0.5 times 0.5 divided by 45? Take the square root of it? Because otherwise,
I use P.
yeah. Don't make me remind you to choose pi. We're going to learn the hard way. But more importantly, what's the test statistic here? 0.19 divided by 0.075. Chris, again, please.
2.53.
What?
2.53.
2.53?
Repeated over 3.
Repeated on the 3. I'm not going to do that. But no, we do not reject the null. We accept the null. We accept the null because it's a two-tailed test. Had this been a one-tailed test and we were saying, is the NFC cheating? We would reject the null. Had we chosen a value other than 0.01 for alpha, like 0.05, why our critical value would have been much closer to 2, and we would again reject the null. But because this was a two-tailed test, and because we chose an alpha of 0.01, we don't get to conclude that the NFC was a cheater. We only get to conclude that we accept the null, that no, someone is not receiving an unfair advantage. because that's how things go. We expect 0.5. We observe 0.69. This is a non-directional test. Had it been directional, we would have had a different decision. A non-directional test is a two-tailed test. The significance level is 0.01. Had it been 0.05, we would have had a different result. Because this is pi, we're using z. Degrees of freedom do not apply. We've got two critical statistics because it's a two-tailed test. Sampling error, in this case, is 0.19 because we're talking about 0.69 minus 0.5. Standard error is going to be this one. Our test statistic is this one. And we have to accept the null. Which is why questions such as, what is the p-value for this hypothesis test? .53. 0.4943. 0.0057. How many tails in this test? 2. So it's 2 times that. .0114. Pretty close to that. I'll do one more if you want to do one more. Yeah? All right, we'll do one more. We'll do the slot machine, and then the other 3 in the middle, or 4 in the middle, or however many we didn't get to. Just slow-mo the video so that you can look at the answer key. Research in the gaming industry showed that 10% of all slot machines in the United States stop working each year. Short's Game Arcade has 60 slot machines and only 3 failed last year. Use hypothesis testing procedure at 0.05 level to determine whether this data contradicts the research report. Is this mu or pi? Mu or pi? Mu or pi? You already checked out.
Yes.
I'll see you in 12 hours. 13 actually. See you in 13. Pi. Yeah, I'm talking about proportions. Because that is a value which I expect. And 3 out of 60, or 1 out of 20, or 5 out of 100, or 0.05%. Yeah, dig it. N is 60. Looks like alpha is 0.05. Because I got pi, we're going to need z, both critical and tests. Directional or non-directional hypothesis? Directional or non-directional, James?
Non-directional.
Non-directional. I don't see a direction in there. We just want to know if somebody wrong or somebody contradicting. Because if our data was the same as the report, we would say it's the same as the report. If it's different, we would say our data is different from the report. And that looks like a two-tailed test. For the critical values, separate our distribution into regions where we would accept the null or reject the null. Test statistic, sampling error or standard error. Kind of want a soundboard. Y'all ever play with those things? Where it's like you get celebrities clips from all their movies, and then you can press a button, and then you'll have like Arnold Schwarzenegger saying a bunch of his different catchphrases. You can just press a button, people use them for prank phone calls, and that was a thing people did like 20 years ago. Anyway, I just want a soundboard of like the 10 things I always say. That way I can cut back on my throat lozenge expense. Test statistics, sampling error over standard error. Sampling error is what I observed minus what I expect. Standard error. I'm going to choose pi. You choose whatever you want. I'm going to choose pi. And 60. 0.09 divided by 60 is sort of like 9 divided by 630, which could be 1 over 70. Square root of 1 over 70, sort of like square root of 164, which is like 1/8, but a little bit bigger. Is this like 0.14 for a standard error? No, shoot. How close?
0.037.
0387? 0.0387? Yeah, shoot. Where did I go wrong? Y'all know that I ended up here as a result of a coin flip, right? Did I ever tell you that story? Yeah, I was wondering. 2003, I flipped a coin, decided where I was going to go to school, what I was going to study in graduate school. So there's another reality somewhere where I'm not doing this. 0.0384? 87. Wow, that's interesting. Oh, I forgot to get the test certificate, the credit card. Alpha is 0.05 for two-tailed tests. 1.96 and negative 1.96. This gets me a test statistic of about 1.2 something. 1.2 what? 9. Thank you. Negative. Oh, shoot, you're right. Negative 1.29. Let's accept the null. 1.29er means that my p-value is 0.1970. Twice that, subtract 1. I expect 10%. I observe 5%. This is a does it contradict? Does it contradict means non-directional. One or two tail test. Non-directional means two tail tests. The significance level, 0.05. T or Z, pi means Z. Degrees of freedom do not apply. Critical values, we got 2. Sampling error is negative. Standard error doesn't sound like either one of those. Oh, it sounds like this one.
181.
Say again?
181C.
Yeah. That's the value you gave me, I think. Yeah. The test statistic is going to be negative 1.29. We're going to accept the null. And then our p-value was what? Something like that?
Yeah.
Yeah, because it was basically 80% subtracted from 1.
Wait, no less than the general policy.
I did.
Okay.
Sorry, it's shorthand. So if it's a two-tail test, I got two options. I can either say take 1.29, I can take that value, subtract it from 0.5 and double it, or I can double that and subtract it from 1.
Okay.
Either way, we're accomplishing the same thing. You double that and you get 80%, you take 80% from 1, you get about 20%, and that's the value that looks like 20%. See, that's why I can't do math anymore. It's because things are just close enough. enough rounding, and then it doesn't really matter. Life is easier.
Can you do the first page? Well, it's not like if you're crap down.
Question? Yeah, a little winded right now. Head's buzzing a little bit, I should expect. Do you ever get rattled, Christine? Apparently not. Apparently not. Ice water in your veins. I love it. I want you on my team for whatever it is you do. What are you good at?
I don't know.
You're good at this. What are you studying?
My
Mark?
major?
Yeah.
I'm a finance major.
Yeah. Yeah. You want Christine on your finance team. That's for sure. Any other questions, comments, concerns, thoughts? I'll go over the first page. I don't need to stream it or anything because we already did it. All right.
Thank you.
Yeah. Good work, y'all.